Hi, thank you for joining us today. My name is Ann Townsend. I'm a part of the MITRE Corporation, and I'm joined by my colleague, Dr. Mike Hadjimichael, also a part of the MITRE Corporation. And we're here today to talk to you about this term, this idea of AI powered. Are things really AI powered, or is it just hype? So when we're at cybersecurity conferences like today, being at RSA, when we walk out to the expo floor, we have a wealth of resources we can use to talk to these cybersecurity vendors about the product that they're providing to us. If I wanted to know how they're securing their product themselves, I could look to something like the NIST 853 security controls, and I could find out how are they securing their data? I could ask them questions about user access controls, user privileges, but I could really start to understand about the security that they put on their device themselves. So if I was to be an adopter of their tool and I bring this into my enterprise, I realize that what kind of security implications I could be bringing into my enterprise. On the same accord, I could also ask them questions about what kind of capability they're providing me. I could say, would you be able to help me identify vulnerabilities within my enterprise? Or could you help me better protect my enterprise? Or I have no ability to recover. Are you able to help me with this at all? If you're familiar with the NIST cybersecurity framework, those are the functions that are within the framework, and it really helps me understand really what they're going to provide for me. What's great about this dialogue is it really lets vendors understand as a potential tool adopter what I'm looking for, what I need, and it can help them to drive how they produce their cybersecurity products. Conversely, as the adopter, when I'm asking these kind of questions, I can kind of start to understand what I'm really getting by adopting this tool. The other great thing about this wealth of resources I have to asking these questions is it doesn't really reveal any intellectual property. I'm not asking questions that a vendor should really be uncomfortable in answering because they might be revealing their own secrets. But at these conferences in the last few years, you'll notice that there's been a lot of buzzwords about AI being dropped, right? AI enabled, AI powered, we use AI for the better. But there's this question of that dialogue that we're having about cybersecurity. Does it really translate to understand that AI component? So I want to put a pin there. I want that question to kind of think in your mind for a minute. And I'd like to move to the idea of AI. Next. So this slide, I could go down a rabbit hole. We could talk in the world of adversarial machine learning, and it's fascinating, a fascinating world. But I need to just bring it up one level to kind of illustrate the idea that there's still a lot to learn with AI, especially when we want to talk about AI and its consequences. So if we look at these images, the ones that almost is in the middle of this screen, I, as a human, I look at this image and I know that this is a pig. It's labeled as a pig. In the world of adversarial machine learning, there's what is called an evasion attack. And to this digital image, there's a slight perturbation, which is what this equation is about, adding this little gradient kind of noise to the image. It's the human eye can't see it, but it's been placed within the digital image itself. And as a result, we get this picture that's over on the other side of the equal sign. Again, as a human, I look at this picture and I know that this is a pig. But for this example, this image classifier saw this pig as an airliner. If I move to the left side of the screen and we talk about this stop sign, this one, there's a perturbation, but obviously this is in the physical world. So I can see this as a human. I know it's still a stop sign, but I see that there's graffiti on it. If I'm driving my car and I'm approaching an intersection and I see this stop sign, I know I should stop my car, regardless of the fact that there's graffiti on it. But in this example, this image classifier, when it approaches the stop sign, it sees the stop sign as a 45-mile-per-hour speed limit. Think of the consequence of approaching that intersection and proceeding at 45 miles per hour. Next. So I want to put these two thoughts together. So the last slide about AI, I picked on adversarial machine learning. I talked about security. But as an AI component, besides security, there's other things I'm going to want to know when it's a critical part of an AI or a cybersecurity type of product. So some thoughts would be, with this AI component, is it really doing what it should be doing? Is it doing a good job at that? Really, that's really a high level question. There's some heavier questions I'll want to answer to kind of dig into that space. There's also the idea of, this cybersecurity tool could have an AI component, but is that AI component really doing any of the cybersecurity functionality? If I'm being told their cybersecurity tool is AI powered, I would hope that it is, but is it? And there's also the idea of cost. And cost, we immediately get to the idea, jump to finances, right? And financial is a huge impact that could be there. But think about my last slide. There's a cost when it comes to cybersecurity itself. Is it possible that this AI component is really introducing vulnerabilities or security issues into my enterprise? Okay, so the first slide, I took you kind of on a mental field trip onto the expo floor. Now I want to take you on a mental field trip like back in time. Next. So rewind time 5, 10, 15 years ago. Cybersecurity's advances, again, we had these questions that were kind of coming up alongside of cybersecurity. The first one we could think of was, or as an example, do we understand adversary attacks and techniques, right? If we could really understand adversary attacks and techniques, we could really, as a result, have better cybersecurity. So a lot of research went into this, a big initiative went into this, but as a result, we came out with a tool such as ATT&CK. On a similar note, we could approach cybersecurity with the question of, is there a way that I could make cybersecurity decisions, but through a risk management approach? And again, a lot of research went on here, a lot of community involvement went on, but NIST came out with a cybersecurity framework to address those concerns. In more recent years, we've had the questions of, can we capture and organize what we learn about active defense and adversary engagement for better defense? Again, this is another huge research initiative, right? But it resulted in something like MITRE Shield. And then taking that idea of the NIST cybersecurity framework and pivoting it to the idea of privacy, we could also talk about a risk management approach, but addressing the privacy space. And we have a framework like the NIST privacy framework. Again, we had these questions kind of paralleling the world of cybersecurity, and as a result of putting research and initiative into it, we came out with frameworks or tools or resources to help us address those questions. Next. So at the National Cybersecurity Federally Funded Research and Development Center, which is operated by MITRE, we've started on a research initiative to really kind of address those questions about the AI component of a cybersecurity tool. Our goal in this research initiative is really to offer a better understanding of the AI component. We want to be able to jump into that dialogue with cybersecurity vendors and understand the cybersecurity, but also start to get into what's going on with the AI component as well. The way we've approached this research initiative is we've started off focusing on cybersecurity. So something that's a cybersecurity tool that's AI enabled. But in reality, the way we're approaching it is that this framework that we're talking about could be used in other dimensions as well. It could be used in health IT systems that are AI powered. And again, back to the beginning, we want to make sure that the way that we're asking these questions, we're keeping with that dialogue in which a vendor would be comfortable in helping in answering it. So we're not interested in getting into intellectual property or doing any type of reveal of proprietary development. Again, the goal is really to continue to help facilitate that better dialogue between the vendor and the potential tool adopter for both sides to win. The vendor's really going to understand what is the tool adopter interested in, what are their concerns, and then the tool adopter themselves can really understand what are they getting should they decide to adopt something that's AI enabled into their enterprise. So ultimately, our goal is to really assist in developing a tool that an organization can use to really start to understand, is something really AI enabled, or is it really just hype? I'm going to go ahead and turn it over to Mike at this point, and he's going to jump into talking a lot more about the framework that we're looking to develop. But along the way, if you're interested in asking us any questions, we do have the chat running. You're welcome to drop any questions in the chat as the presentation proceeds. Mike, over to you.
Thank you, Anne. So now I'm going to present our ARCS framework. ARCS, of course, stands for AI Relevance Competence Cost Score. And this is the tool that we're proposing today. The goal of ARCS is really to develop a methodology for assessing an AI-enabled product. Okay. The framework is organized around a structured set of questions. Answers to these questions provide a score, an assessment score, and guidance for an acquisition decision. So as we thought about this, we realized that there are essentially three questions that sort of drive this. Is AI necessary? Is it functional? Is it cost effective in this particular tool, in this particular case? And these three questions kind of lead us to three dimensions. So first of all, we think about, is the AI, how necessary and appropriate is the AI in this component? And that's the relevance dimension. We know that sometimes you can have AI it's there, but it's not really crucial to the system. So is this a good place for AI or not? We're also interested in the competence. How well does it do what it claims? That's our second dimension. And our third dimension really is the cost-benefit analysis. So we have relevance, competence, and cost as our three dimensions of interest. Clearly, there are a lot of other ways of assessing systems. These aren't all the questions or all the ways of assessing an AI system. But these are the ones that focus on an initial screening for the acquisition process. If you're really considering adopting a tool, you've got to start somewhere, and this framework provides a set of questions that will help you kickstart that assessment process. Okay, the goal is to be accessible. We're not relying on proprietary or deep technical knowledge. We're looking for accessibility and a quick screening tool to get started. So I'm going to address now the three dimensions. And the first dimension of these is relevance. Okay, so is AI the right tool to solve this problem? And is it the right kind of AI, in fact? If you're using a machine learning system, you need to know, is there relevant data to support this tool? If you're doing an expert system, is it in a field where sufficient subject matter expertise exists? And is the data that you have, is it the right data? All these things will help you understand if AI is the right tool and if it's the right kind of AI for this application. Centrality is another place we're looking at. Okay, so is the AI central and significant to this system? Imagine an AI component that fails. If it fails, does the entire tool fail? And in which case it was probably pretty central. If the AI fails and the tool is still quite functional, then you say, okay, it was not particularly central to the system. So we're looking at how much of the overall functionality depends on AI. Think about an AI-driven chatbot, for example. It does natural language processing. It understands the user's questions in an interface, but all it's doing perhaps is pulling out frequently asked questions. If that's the case, it's not really bringing a lot of extra functionality or extra value compared to just having a frequently asked questions list. And finally, for relevance, we look at is the AI necessary, and is it necessary at the right level that's been implemented? Sometimes AI can just be gratuitous. For example, did you need the chatbot, or is it gratuitous? Consider a situation, for this in this trivial example. If I need the floor swept, I can put in a floor sweeping robot, as in the illustration, or I can go full on with a walking, talking, automatic robotic maid. Clearly, there are various levels of AI, and you need to choose the one that's appropriate to the project. You don't want to get more or less than you need. No more, no less. So after relevance, we look at competence. Measuring competence, of course, when you don't have a lot of information, you don't have insight into the system, is challenging. Usually one thinks about accuracy, precision, recall, and other such metrics. But in this case, when we don't have that kind of information, we're interested more in the comparative performance of a system, comparisons to industry standards or typical industry performance. Various fields have different metrics, so you have to choose the right metric for the field you're interested in. But without looking at the inside of the code itself, all we can do is look for comparative performance. And that's our standard for understanding performance at the competence dimension. So when you take a system out of a lab, however, whatever benchmarks or scores you got in the lab may be different in the real world. What we really need to think about is the operational issues you deal with when you bring something into an operational context in the real world. So for example, things like a model drift and retraining requirements. It does happen that a system that uses machine learning that was trained on one set of data starts performing well in the beginning, and as that data changes for some reason, the model no longer performs accurately. So does your system, the system you're considering, does that system accommodate for that kind of drift? And if it does it require retraining or not? So these are the issues that come about when you bring a system into the real world. And finally, transparency. We want to know if an AI system provides the transparency and explainability into its output, so that the system has to reveal behavior in a manner that lets you monitor and improve its performance. These are the three areas of competence that we're going to look at within the framework. So after relevance and competence, we understand that the AI belongs where it is. It's doing, hopefully, a good job at it. But finally, there's one last consideration, and that is the cost. Okay, and cost obviously is more than dollars and cents. Okay, integrating a system involves tuning or specialization. Think about the case where you have a natural language processing system. It does understanding, but it's been trained on, say, data scraped off the web. Okay, it's going to have a very general ability to understand the English language, for example. Now bring that into your operation where you have jargon. Okay, it's no longer going to be function the same way. So if you bring it into something like air traffic control or even cybersecurity that might have a lot of jargon, the system may no longer understand and perform as advertised. AI may also increase the accuracy of your system, which sounds really good, but that increased accuracy may come at a cost of increased processing time or increased memory or other resources. So there's a cost-benefit analysis there as well. Did the increased accuracy slow down your system? So finally, we're interested in the security, particularly in this context. Understanding that adding AI may introduce unmitigated vulnerabilities, and gave a nice description earlier of how adversarial machine learning can be used to attack an AI system. In fact, adversarial machine learning is increasingly democratized. It's in the hands of anybody who is interested now. There are well-documented attack modes, libraries and software, and so on, that make it easier for adversaries to attack systems in one way or the other. Many machine learning systems now are trained on publicly available data sets, and those data sets might be corrupted by an adversary. Poisoned is the term we use. And if that poisoned data gets into the training system, in the trained model, then you have another vulnerability. So understanding that, to get the advantages of AI, you also have to consider the vulnerabilities that you're getting at the same time. So it turns out there's not usually enough information available to give really definitive answers to some of these questions. Okay, the questions of relevance, competence, and cost are important. We try to get as much information as we can, but sometimes the information isn't always there, or it's not there in necessarily trustworthy sources. So how do we deal with that? Well, what we do is we make our best estimate, and then we weight the result according to our confidence. And we measure our confidence according to the quality and the quantity of the supporting information, the supporting materials. So if you consider something like transparency into the model and the supporting data, this is something that we can look at and understand. A useful source of that kind of information is even something called model cards and data sheets. These were developed at Google and provide documentation about the model, where it's appropriate to be used, how it was trained, what it was trained on, what biases or flaws it might have, and data sheets document the data sets, how they were developed, what they're appropriately used for, what pre-processing or de-identification has been done. So there is information out there, or there could be, that provides that kind of needed transparency. Publications and patents, especially peer-reviewed publications, are fairly trustworthy sources of information. And if those are available, those can give you the answers you need with a high degree of confidence. White papers and publicity materials, of course, if they're not peer-reviewed, may be less, you may have less confidence in those, although they may also provide some information. So we take all this into account to understand exactly how confident we are in the answers that we generated for the 3 dimensions of interest. So once we consider all this, we have relevance, competence, and cost. We aggregate this all and weight it by the confidence in the answers we got. And we end up with the ARCS tool. So what's in the box in the ARCS tool? ARCS provides a hierarchically organized list of questions. So in the upper left there, you see the questionnaire and stored in a spreadsheet at this time. These questions are really the questions that reflect the features that the tool is assessing. You also get a scoring system that tells you for each answer what value, how it's scored, what value to assign to it. The inference method is the part that takes all those scores and aggregates them to give you a final score. And last, and certainly not least, because of its importance, the guidance to how to ask, how to use the system, what questions to ask, how to do the scoring, but also, and very importantly, if you don't have the answers you need to answer these questions, guidance is what tells you these are the questions to ask the vendor. So if you're considering acquiring a tool, you have now questions to answer. When you can't answer them, you can go with those questions in hand to the vendor and say, this is the information that I need in order to make a purchasing or acquisition decision. So to wrap up, we've provided a tool that lets you, in a consistent way, assess a system and provide a score that you can use to compare to other systems. It's important, very important. Nobody wants to end up, disappointed and regretting an expensive acquisition. So by using something like our ARCS tool, you can start to understand if you got what you paid for and if you're getting what you need. So finally, what have you learned today? First of all, it's important to take a structured approach to assessing AI-enabled tool acquisitions. You have to be able to ask the right questions and ask them consistently across all tools under consideration, and to be able then to compare those tools within that common framework. Not every AI-enabled claim is equivalent, and if you have the same metric to use against all AI claims, you'll be in a better position for making good acquisitions. Longer term down the road, purchasers, if you are looking to acquire tools, this ARCS tool will help you to actually make that assessment. So you should be able to learn how to use and apply this tool, and your feedback, in fact, will help improve that tool. Vendors, product developers, if you use ARCS, you can see how your tool rates, how your product rates, and in fact, you can also look and see the results of your assessment can drive your public documentation. If you see that you haven't provided the information yet to the public that helps them make their decision, maybe this will drive better documentation for you. So we are really excited to get this out into people's hands. If you are interested in working with us, please reach out if you're a vendor and you want us to take a look at your tool or work with us to help improve your tool. If you are looking to acquire a tool in general and you want us to help you, please feel free to contact us at the email on the screen. We're really excited to work with the public on this. Thank you very much for your time and attention today.